Okay, in this video we are going to discuss solutions for practice problems example 12 to example 17. These are problems related to limit and continuity of function of two variables. So let's go over it. All right, we start from example 12. So for example 12, I want you to find constants a and b that satisfy this equation. So when you see this equation, you can see that this is just a basic computation, right? Because, well, you have x, y approach e square comma 4 here. So you can just trying to compute limit on the left hand side and see if you can simplify it to the right hand side. So for the left hand side, you have limit where xy go to e square comma 4 of log square root xy. So you can plug in numbers. So you get log square root e square times 4, right? Simple like that. And then you simplify a little bit, so you get log 2e. So when you have log 2e here, you can use property of logarithm because you know that log of product equal to summation of log. So this is going to be log 2 plus log e, and that is 1 plus log 2. Wow, this is pretty simple and easy, huh? So at the end, your conclusion is going to be, hey, a equal to 1 and b equal to 2. That's it. All right, pretty simple. So let's move to another one. So example 13. So now we need to compute limit. So starting from 13.1, well, we look at this limit. So you can see that you have to try to compute the limit by just plugging in the number first. So I'm trying to plug in numbers x, y go to 6, 2 here. If I plug in the number x equal to 6 and y equal to 2, well, I'll get 0 over 0, right? Well, that means this is an indeterminate form. So you need to do something to compute this limit. And of course, so you can factoring. Well, the easiest way to do this one is you just factor x on the numerator. So you're gonna get x minus 3y. Then you can see, wow, this is easy, huh? Because something cancel, right? Because x minus 3y gonna cancel out. So you have limit just x. And when x comma y go to 6 comma 2, well, this is just x, it's go to 6. Well, that would be your answer. Just simple like that. All right, next example 13.2. Well, again, if you try to plug in x equal to 1 and y equal to 2 into this limit, so you're gonna get 0 over 0, which is actually indeterminate form. For this question, you could try factoring, or you could try something called conjugation. So the method I choose, I am going to multiply its conjugate. So because I see square root y minus square root x plus 1 on the top, I am going to multiply square root y plus square root x plus 1 on the top. And to balance it, so I need to multiply square root y plus square root x plus 1 in the bottom too. Well, this means I just use number 1 to multiply the original form. So this is valid. So I can keep going. Now I can just multiply two terms on the numerator. So I am going to get y minus x plus 1 here, right? Because on the top, well, I have a minus b multiply a plus b, right? So that will give me a square minus b square, which is just y minus x plus 1 in parentheses. All right, on the denominator, I keep everything clean. So y minus x minus 1, and then square root y plus square root x plus 1, because, well, I hope that something gonna cancel out. Well, for sure, on the top numerator, y minus x minus 1 gonna cancel out with the same term in the denominator. So at the end, you're gonna have limit xy go to 1/2, and then 1 over square root y plus square root x plus 1, and this is 1 over square root 2 plus square root 2. So this is square root 2. Sorry, this is 1 over 2 square root 2 square root 2 over 4. All right. So for this question again, if you try to plug in number x equal to -1 and y equal to 1 into this function, you can see that you're gonna get 0 over 0, which is indeterminate form again. So you need to do factoring or conjugation or something similar to those two techniques. So you can see that even it is a little bit hard to factor, but we could try, right? We could try. So we can try to factor something on the top. So, well, let's do it. So this is limit x, y go to -1, 1. All right. So I'm gonna try to factor out the numerator. So, well, the first term that you see here, you have 2x squared. So maybe I will try to do x and 2x, right? It will give me 2x squared. And then the last term in the numerator, this is actually minus 3y squared. So maybe I'm gonna split it to y and 3y. So I'm gonna do y here and 3y here. All right, and you can see that well, I hope that after factoring, I hope that something gonna cancel out. So maybe I'm gonna put my plus sign here, because I do expect that it's gonna cancel out with the denominator that I have, and then I have a negative sign here. So let's double check that your factoring is correct. So you can try to uh, multiply it back, and then you will see that the numerator can factor to x plus y times to x minus 3y. Alright, for sure, something cancels out again, and this is going to be just 2 times -1 minus 3 times 1, and this is actually -2 minus 3, which is -5. This will be your final answer. So I consider example 12 and example 13 as easy one. Well, if you see this question on the exam, this is supposed to be easy one. All right. Next one is example 14. I want you to show that this limit does not exist. So when you see the question does not exist here, well, it is pretty clear that you need to show that the limit does not exist. Well, we already learned in class that we have one way to show that the limit does not exist. So we can pick two different curves, and then if we find that the limit on different curve, they approach different numbers, so we can conclude that the limit does not exist. So we're gonna use that approach here. So that means you need to pick the lines that approach 0, 0, and then trying to get different limits. So well, we're gonna start the easy one first. So we're gonna pick x equal to 0. We can do it because x equal to 0 approach uh, the origin 0, 0 as well. So if I pick x equal to 0, then I have limit x, y go to the origin on x equal to 0. Here gonna be x minus 4y over 6y plus 7x. Well, when I plug in 0 here, so I'm gonna get limit 0 minus 4y over 6y plus 7 times 0. Well, this is actually, if you cancel everything out, well, what you get is you get negative 4y on the top and 6y on the bottom, and then they cancel out again for y, and then you get at the end negative 2 over 3. Alright, negative 2/3, this is your limit when you pick x equal to 0. So I can pick different line here. Well, and then you can see that we're going to start from the easy one. Maybe you pick y equal to 0 first, because this is the easy one. Alright, and then if you pick y equal to 0, you can see that, well, the limit you get is x minus 4 times 0, and then 6 times 0 plus 7x. Well, actually, when you cancel out everything, so you're gonna get 1 over 7, right? Well, these two numbers, they are not the same, right? They're not equal to each other, so that means at the end your conclusion is gonna be since negative 2/3, which is the limit from picking x equal to 0, is not equal to 1 over 7. This is the limit. When you pick y equal to 0, we conclude that limit x minus 4y over 6y plus 7x does not exist. Alright, this is still super easy, right? Alright, next we're gonna move to example 15. Determine if the following function is continuous. Alright, this is a typo, so we need to check that the given function is continuous at the point 0, 0 or not. Alright, let's see. So in order to check that the function is continuous, you need to show 3 steps. So the first one, you need to show that f at 0, 0 exists. So for here, you can see that f 0, 0 equal to 0 by the definition of f, right? Because the function f is given in the cloud, in the green cloud here. So you can see that when you plug in x equal to 0, 0, so you get 0. Alright, number 2, you need to compute limit of fxy when xy go to 0, 0. Well, for the limit, you just need to consider the point in the neighborhood of 0, 0, right? So the function that you're going to use is going to be the top one here. So actually, this is going to be limit x cubed minus y squared over x cubed plus y squared. Alright, where x, y go to 0, 0. So you can see that the problem just go back to computing the limit. And how will you compute this limit? So if you try to plug in x, y equal to 0 into the function, so you're going to get 0 over 0. This is actually indeterminate form. Well, if you try to factoring, or if you try to do the conjugation, you can see that it is impossible. Well, I hope you try already. Well, maybe I need to pick the line then. So that is another technique we can do. So maybe I'm going to pick, well, you can see that the standard technique, if you pick x equal to 0, the limit that you're going to get limit x, y go to 0, 0 on x equal to 0. If you plug in x equal to 0, at the end you're going to get 0 minus y squared, 0 plus y squared here, which you get negative 1, right? And then if you pick another line, suppose you pick y equal to 0, you can see clearly that now if you pick y equal to 0 here, so your limit gonna be x cubed minus 0 over x cubed plus 0, which is actually just 1. So these two numbers, they are not equal to each other, so we conclude that the limit fxy where xy go to 0, 0 does not exist as well. Well, because the limit of the function f does not exist, we also conclude that the function f is not continuous at the point xy equal to 0, 0. Does it make sense? All right, I hope you still fine with this example. All right, we have two more. So example 16, this is the big one because you have three sub questions. So example 16, I want you to evaluate limits. Well, in case that the limit does not exist, explain why. So I mean, if the limit does not exist, you need to show your work. So the first one, you can see that, hey, for 16.1, you have this limit. And well, if you try to plug in 0, xy equal to 0, 0 into the function, you're gonna get 0 over 0. Well, and keep in mind that when you see the denominator x squared plus y squared and take square root here, you have no chance to factoring or do the conjugation. So you need to use other technique. Well, I hope you try it already, and you can see that if you pick the line, so many line, you still get 0. And this will lead you to the idea that maybe it is actually 0. So we're going to use the thing that I call two-dimensional squeezing theorem. So what are we going to do is we are going to let fxy to be xy. Well, I don't know yet. So let fxy to be something like some ratio here, and gxy to be something. So basically, we're gonna split the one that I highlight in green here into f and g. So first of all, we're gonna do the as we did in class. So we're gonna keep x squared plus y squared with f, and then, well, let's try to bound it first. So condition number one, we're gonna compute absolute fxy here. We need to bound it with some positive number m. So what should I pick on the top here to get the easy bound? Because at the end, you want a single number that can bound this absolute f. So maybe I just try x first, for example. Let's say I try x. So if I try x here, so what I'm gonna get is I can say that the absolute x on the numerator, I can say that this is square root x squared, which is pretty good, huh? Because you can see that the good thing if you pick just x here, so it's gonna with together with absolute, so you're gonna get absolute x, and it's gonna be square root x squared here, which is a good one for you because you want it to be less than or equal to square root x squared plus y squared, or which you can do it for sure because y squared gonna be the thing that is greater than or equal to 0, so x squared uh, must be less than or equal to x squared plus y squared, and on the right hand side you get 1, so you get the bound already. So that means you just keep x with the f, and then the remaining gonna go to g, which is xy squared. Alright, condition number 2, I compute limit of the function g. Well, the limit of the function g, and that is the limit of xy squared. Alright, you plug in the number 0, 0 here, you get 0. Well, from the condition number 1 and condition number 2, we can see that by two-dimensional squeezing theorem. Well, the name of the theorem here, I just made it up. You know, if you Google two-dimensional squeezing theorem, it does not exist. But, well, because this theorem, it's similar to squeezing theorem in two dimension, that is why I name it. So we can call it together in class easily. So we conclude that the given limit x squared y squared over square root x squared plus y squared, this is indeed equal to 0. Sounds good? Alright, that is question 16.1. Note that the solution is not unique, so you can pick different f and g compared to my solution. Well, some of you are gonna say, Ajahn, can I pick absolute f to be absolute y over square root x squared plus y squared? That is fine too. Well, the choice of f and g is not unique. All right. We're gonna move to 16.2 now. So 16.2, again, if you try to plug in the number first, you're gonna get 0 over 0. And when you see the x squared plus y squared here, again, you do not want to factor because that's no way to factor it easily other than using complex number, which is not our approach for sure. So we're gonna just skip the factoring or conjugation technique. So the one that we can do is maybe you're gonna pick the line. So let's try to pick the line first. So I'm gonna try to pick let's say x equal to 0 first. Well, x, y go to 0, 0, and then if I pick x equal to 0, what happened? So I have 0 minus 0 plus y squared over 0 plus y squared. Well, I did it too quick here, but well, on the full solution on the exam, you need to just go slow step by step. But here you can see that y squared and y squared cancel out, so you get 1. Well, what if I pick another one, which is x, y go to 0, 0 on y equal to 0? What happened? So I have x squared minus 0 plus 0 over x squared plus 0, which is actually 1 again. You can see that this is not simple. Huh? Maybe you need to pick another line. You need just to find another one that give you different numbers. Well, you still want to do this approach because you can see that the limit here, what you get is 1 and 1 here. So the limit will not be 0 for sure. Because if it is 0, it must be 0 on every single line, every single curve. Well, but here on the first two curve that you pick, so you get limit equal to 1. For sure, the limit is not going to be 0, but yeah, let's try to pick another one to get different number here. So other than x equal to 0 and y equal to 0, maybe we're going to pick x equal to y. Well, this is another one that is easy. Well, as we show you in class, so you have x squared minus 2 times x plus x squared. All right, that looks pretty good though. And then on the numerator, you have x squared plus x squared. All right. On the top, you can see you have 2x squared minus 2x squared. Good. So you get 0, right? Wow. This is a good one. So you have 1 and 0. So they are not equal, right? Well, they do not equal. So they are not equal to each other. So they're not equal. So that means the limit does not exist. All right. The limit of this function that is given in the question, it does not exist. All right. Good. All right, next, let's do 16.3. All right, so this is the one that maybe you're gonna have a hard time with it because you see that you have x to the fourth power and y to the sixth power in the denominator. So, well, you have to pick uh, your method carefully. So first of all, if I try to plug in 0, 0 again, you get 0 over 0. And you do not want to do factoring or conjugation because you have psi here, psi x, y. It will not be easy for sure if you're trying to do factoring or conjugation. Well, if you try to pick the line, pick the line, pick the line all the time, you're gonna get all 0. You can try it, you're gonna get all 0. Well, this is because you have psi x, y here, and this term gonna dominate your limit to 0. But well, you need to find the way that you're gonna show that this limit is equal to 0. Can you follow me? Because you know what? When you listen to my solution, it's gonna be quick because I already know how to do it. But when you start working with it by yourself, it's gonna take time for you to get started and pick the method you want. So let's suppose that I already picked the line and then I pick so many lines. I all always get 0. So that means maybe the limit is actually 0. So we're gonna use the thing that we just did in 16.1. So we're gonna use the same method. So we're gonna try to split this thing to f and g. Alright, for sure, x to the 4th power plus y to the 6th power. This must be with f. Well, let's do the bound first. So number 1, I have absolute f, and this is absolute. Well, on the numerator, I have x to the 4th power plus y to the 6th power. Well, how do I bound this thing? How do I bound this thing? This is so crazy. So the trick here, well, you have to see it one time so you know how to do it. Uh, well, at the end, I need a single number that is the upper bound of this absolute f. So observe that this is a trick. Observe that when you have x to the 4th power plus y to the 6th power, you can break it to square root x squared x to the 4th power plus y to the 6th times square root x to the 4th power plus y to the 6th, right? Well, you can do this because the square root 2 times going to go back to the something raised to the uh, first power, which is amazing. Now we can see that, well, you look at my yellow highlighter. So I have x squared x to the 4th power plus y to the 6th square root here. So if on the top I have something like square root x to the 4th power, that would be good, because I can group it up with, I can group the yellow one together, right? And then I can have a bound that I want. At the same time, if I have square root y to the 6 with me, that would be good too, because I can group this thing, the green one, together. And then on the next step, I am going to have to say that this is bounded by square root x to the 4th power plus y to the 6th, x to the 4th power plus y to the 6th, x to the 4th power plus y to the 6th, and then square root x to the 4th power plus y to the 6th, and everything cancels out to be 1, which is good. So the key idea that you use here is just x to the 4th power less than x to the 4th power plus y to the 6th power, because, well, you add something positive, so it must be true. And then the green highlighter here, y to the 6th power take square root. This must be less than or equal to x to the 4th power plus y to the 6th take square root. Well, because you add this term x to the 4th power, which is always non-negative. All right. Well, if you see the big picture here, you can see that you can fill in the function you want. So because you need this pattern, so you're gonna save x squared and y to the 3rd power y cube here. So I'm gonna do x squared and y cubed with f, and then my g gonna be the remaining thing, which is y squared sine xy. Well, this is the standard way that we always do. So memorize this technique because you probably see it again on the exam. All right. Number 2 here, I need to compute limit of the function g. Well, the limit of the function g, this is going to be the one that you see limit of y squared sine xy, which is going to be 0, right? Because you plug in 0 to that function. So from 1 and 2, now you can conclude we conclude that this limit x squared y to the 5th power sine xy over x to the 4th power plus y to the 6th power, this is actually 0. Alright, that's question 16.3. Alright, the last one, x equals 17. So find the value of k such that f is continuous at -1 and 1. Well, you need the function f to be continuous at the point -1, 1. So that means the first one, you need f -1, 1 to be the number that we can compute. Well, this is actually k minus 2. So save it for later because step 2, you need to compute limit of the function f where x, y go to -1 and 1. Well, once you get the number from step 2, you can just set it equal to be k minus 2, and then you solve for k, and that will be condition number 3, right? All right, so let's compute limit first. So how do you compute limit this thing? So maybe you try to plug in the number first. Well, if you try to plug in into this function, so what happened? So if you try to plug in, you're gonna get 0 over 0 again. Damn it. So you just need to factoring or conjugate or pick the line or use the two-dimensional squeezing theorem. So, well, because you can see down the top, the function here is nice enough to factor. So maybe I'm going to factor out, and then I hope that it's going to cancel with x plus 1 here. All right, so let's do it. So I can factor x squared minus 3x minus 4 here. So I'm going to factor it here. So what I'm going to get is I have x here, and then, well, maybe 1 and 4 here, right? Because you need -3 in the middle. So, well, let's do negative here plus here. So, well, that's good now. So you can cancel out x plus 1, and then now you can compute limit easily. So the limit gonna be -1 minus 4 over 1 squared plus 2 times 1, which is actually -5 over 3, right? -5 over 3. And then the condition number 3 for continuous function. So you need step 1 equal to step 2. That means we need to set k minus 2 equal to -5 over 3. And that will be k equal to -5 over 3 plus 2. And that is -5 over 3 plus 6 over 3, which is k equal to 1/3 at the end. So k equal to 1/3 is your answer, is the final answer. All right,